The Global Positioning System, or GPS, was designed to provide position, navigation, and time, or PNT services to the U.S. military. Its civilian version has proved incredibly popular. Today, increasing areas of our lives depend on the availability of GPS, including power distribution, financial transactions, telecommunication, and transportation services. But how reliable and secure is GPS? Receivers of GPS and other satellite-based positioning systems, such as Galileo, GLONASS, and Beidou, process very weak signals arriving from space. Typically, no more than 8 GPS satellites are visible from any location on Earth. Unfortunately, jamming or spoofing is relatively straightforward. A hobbyist can, with downloaded code and an inexpensive, off-the-shelf software-defined radio, SDR, transmit erroneous time and positioning data. Our government and military are addressing this vulnerability with urgency, as it poses a serious potential threat to our national security and to many facets of our day-to-day lives. Some of the notable backup solutions for GPS are eLORAN, which is an enhancement of the predecessor to GPS, pseudolights, or pseudo-satellite systems that are ground-based GPS transmitters, low Earth orbit satellite-based positioning systems, which provide stronger satellite signals. These alternatives, like GPS, all use RF signals from which a receiver can triangulate its location and determine the time. They do not offer any meaningful systemic or architectural advancement that can overcome intentional jamming or spoofing attacks. They are similarly sitting duck solutions like GPS from a hacker's vantage point. Introducing PhasorLab's HyperSyncNet, HSN. Over the past 5 years, PhasorLab has, through intense R&D, produced a reliable precision PNT system that can withstand attacks at a fraction of the cost of the alternatives. HyperSyncNet is based on our proprietary and patented technologies, which enable our resilient and agile mobile network to maintain virtual time and frequency lock, and so deliver PNT services using common wireless communication channels and minimal overhead. Some of our key technologies are a high-precision carrier synchronization algorithm, which allows better than 1 nanosecond time and better than 1 part per billion frequency synchronization. A wireless phase lock loop that is tuned using a two-way protocol which is difficult to spoof. A synchronized frequency hopping schedule provides agility and resilience against jamming. A self-organized, self-healing, self-absorbing, and self-discovering mesh architecture offers seamless scalability. Any client node can also be a PNT reference node. Our location-aware network-based authentication also offers an effective safeguard against spoofing attacks. Through integrating these key ingredients into HyperSyncNet, we have been able to develop a robust and secure PNT solution providing a reliable GPS backup. When an attacker tries to jam our system, disabling parts of our mesh network, HyperSyncNet reroutes data packets without disrupting network services. When subject to spoofing attacks, our network-based and location-aware authentication delivers network security. PhasorLab's HyperSyncNet is highly mobile, allowing for rapid deployment anywhere without network pre-planning, thanks to its self-organizing nature. This allows any client to serve as a reference node and provide peer-to-peer wireless data communications. Deploy our units anywhere PNT services are needed and simply turn them on. PhasorLab's HyperSyncNet delivers a true solution to the critical need for assured position, navigation, and timing, or APNT services that our government, military, and critical commercial infrastructure services have long been waiting for. For further information on PhasorLab's HyperSyncNet, please visit our website, PhasorLab.com. Thank you.